All right, let's pull back the curtain on something that pretty much runs our digital lives, but we almost never see it. Software testing. It's the secret world of bug hunting that keeps our favorite apps and websites from, well, completely falling apart. And it all starts with a feeling I think we all know.
You know the feeling, right? You tap that update button, you're excited for some cool new features, and then nothing. The app just crashes the second you open it. Or maybe a feature you use every single day just vanishes. It is so frustrating.
Well, to stop that nightmare from happening, there's this entire hidden process going on behind the scenes. Developers basically become detectives, hunting down these little errors and glitches before they ever make it to your phone. And that whole hunt? That's software testing.
Okay, so to really understand how this bug hunt works, we first have to learn the lingo. Developers have a really specific way of talking about problems, a kind of anatomy that helps them figure out exactly what's gone wrong.
It all starts with something super simple, a human error. Seriously, a programmer just mistyped something, or maybe they misunderstood a requirement. It's just a regular old mistake, a slip-up that kicks this whole thing off.
So that little human error doesn't just disappear. It gets baked into the software's code. And that is what we call a bug or a fault. It's the actual flawed line of code just sitting there, kind of like a landmine waiting for someone to step on it.
And that brings us to the failure. This is the moment the bug actually does something. It's the moment you see the problem. The app crashes, the screen glitches, the button doesn't work. That's the failure. It's the visible symptom of that tiny bug that started with a simple human error.
So we know what we're looking for, but how do testers actually go about finding these hidden bugs? Well, there are two big picture philosophies, two totally different ways of looking at the software. On one side, you've got what's called black box testing. Imagine the tester knows absolutely nothing about what's going on inside the code. They just treat the software like a magical black box. They put stuff in and they check what comes out. Does it do what it's supposed to do? That's all they care about. Then you've got the total opposite, white box testing. Here, the tester can see everything. They're looking right at the code, checking every single wire and pathway to make sure the internal logic is sound.
Okay, so armed with these approaches, testing happens in stages. It's actually a lot like building a house, right? You don't just throw the whole thing together and then cross your fingers hoping it stands. You check your work and build confidence layer by layer from the very first brick to the finished roof. And this process usually breaks down into 3 key levels. We start really small with unit testing, then we see how the pieces fit together with integration testing, and finally, we look at the whole shebang with system testing. So first up is unit testing. This is the microscope level. A developer will test one tiny isolated piece of their code, like a single function, to make sure it works perfectly all by itself. In our house analogy, this is like tapping on every single brick to make sure it's solid, with no cracks, before you even think about building a wall.
All right, so we know our individual bricks are good to go. Now it's time for integration testing. This is where we start putting those pieces together and see if they actually play nice. Can they communicate? Do they work together like they're supposed to? This is us checking to see if our perfect bricks can actually form a strong, stable wall.
And there are a few different ways to do this. You can start from the big picture and work your way down. That's called top-down. Or you can start with the smallest pieces and build your way up. That's bottom-up. And a lot of the time, teams just use a mix of both, which they sometimes call sandwich testing. And that brings us to the final phase of construction, system testing. The entire app is fully built, it's all put together, and now we test it from end to end as one complete thing. Does it meet all the requirements? Is it fast? Is it secure? This is the final inspection of the whole house. We're turning on the lights, running the water, and making sure this thing is actually ready for someone to live in. But even after all of that, after the developers and testers have given it the green light, there's one more hurdle. The software has to face its final frontier, real users out in the wild.
Before it gets anywhere near the public, it goes through what's called alpha testing. This is when the internal team, the developers, the testers, maybe even people from marketing, they all use the software as if they were a real customer. Think of it as the construction crew doing one final exhaustive walkthrough of the house they just built.
And after that, you get to beta testing. Here, they'll invite a small, select group of actual customers from the outside world to use the software. These people are amazing because they find all the weird issues the internal team would never have thought of. This is like inviting your trusted friends to stay in your new house for a weekend, just to see if they notice anything you missed. Okay, let's circle back to that frustrating update problem.
You ever wonder how a company can add one tiny new feature or fix one little bug without accidentally breaking 10 other things that were working just fine?
The magic behind that is something called regression testing. Every single time a developer makes a change, a whole bunch of old tests are run all over again automatically. Why? To make sure the new change didn't break any of the old stuff. It is the absolute critical safety net of software development.
So what happens when a test actually does its job and finds a problem? Well, at that point, the test is done. Now, the real detective work has to begin. This is called debugging. It's the often painful process of tracing that symptom, the crash, all the way back to its root cause, the hidden bug. And honestly, a lot of developers will tell you it feels more like an art than a science. It takes a ton of intuition and experience.
Now, even though it's an art, developers do have some systematic strategies for hunting down these bugs. They've got a few go-to methods. There's brute force, which is kind of what it sounds like. You just gather a massive amount of data and hope the clue is in there somewhere. A bit more elegant is backtracking, where you start from where the crash happened and trace your steps backward through the code. But the coolest one is cause elimination. This is pure Sherlock Holmes. You form a hypothesis, and you design little experiments to prove or disprove it until you find the culprit. But here's the most important takeaway from all of this. The goal of testing isn't to find every single bug. That's impossible. Truly, it is. The real goal is to manage risk. It's about doing the most effective testing you possibly can, with the limited time and money you have.
And that leaves us with a really fascinating and honestly a really difficult question. Since we know no piece of software is ever going to be perfect, how on earth do teams decide when it's good enough? Where do you draw that line between getting it out the door and making sure it's high quality? That is the constant balancing act at the very heart of the digital world we all live in.